Hello students, today we are going to study new chapter 2, relations and functions. Now, we will see what do you mean by relation. In simple terms, in general terms, we say like relation between father son, relation between teacher student, relation between teacher student, or we can see many mathematical examples like this line is parallel to this, like A is parallel to B, P is less than Q. There are numbers which are less, any number is less than other number, or we can say n is perpendicular to n. So these are basic examples of a relation. What does relation means? Means it is simply pairing between or a link between two elements or two objects. It simply means pairing or link between two elements. It simply means this. Now we move ahead in this topic to represent a relation mathematically. How to represent a relation mathematically? So it needs three factors. It needs three factors. First is set. We are representing a relation in mathematical terms. First, we need set to represent a relation. Like we will take an example by we will take an example and understand this by an arrow diagram. This is set A, this is set B. We have taken two sets in which elements are as follows, like DM, RJ, K, 0, 1, 0. You have seen vehicle number plates. These are example from that number plate. So here you can see we need two sets to maintain a relation. Like this element has relation with this. This element has a relation with this element. So initially we need set to define a relation. This is the first condition in a relation. Now we come on second factors, second condition. Ordered pair means how we define this relation. I can say DL01 means this is written like this. DL, the first element is from set A and second element is from set B. So here it is written in open brackets and there are written two elements. It is a representation of relation and it is called as ordered pair. So why we need order in a relation? Suppose let's say we will take example. I am saying that John is father of Sam, but here Sam cannot be father of John. So this is correct, but This cannot be possible because John is father of Sam. Sam is not father of John. So order is necessary to define, to give meaning to a relation. Now we come on Cartesian product. Why we need third factor Cartesian product? To define all the possible relation, to define all the possible ordered pairs from two sets. Like what are they? DL01, DL02, RJ01, RJ02, KA01, and similar KA02. These are all possible relations or all possible ordered pairs. So, how we can get this? By operating both the sets. What is the operation product? So, we need these three factors. So, what do you mean by relation? It simply means pairing or link or connection between two elements. So, to represent a relation mathematically, we need three elements. First, we need sets. Means two sets are needed to define a relation. This is the first condition. Second, we need ordered pair. We need to write in order. Means BL01. It can be, it cannot be like this. This is not a proper way of defining a relation. Okay. Now third, we need Cartesian product. Means we need set of all possible relations. So these are all possible relations. So here we are defining what do you mean by ordered in mathematical terms. The elements written in open brackets from two different sets in orderly manner, where A belongs to set A and B belongs to set B. It is orderly and like this is an example. We have taken two sets in which elements are A, B, C, and 1, 2. Like a relation of A to the element 1 in other set. How we can write this A, comma 1 in open brackets means here this element A belongs to set A and other element 1 belongs to set B. So here we can write this. It is a relation. It is a relation from set A to set B. Means it is a relation between these two elements A and 1. Now, ordered pair has a property. Two ordered pair are equal if the corresponding elements are equal. What does it mean? We will understand this by an example. Here is a question: if x minus 1 comma y equal to 3 comma 2, find values of x and y. Means we will use this property to find the values of x and y. Two ordered pairs are equal if corresponding elements are equal. Means this element must be equal to 3. X minus 1, this belongs to set A and 3 also belongs to set A. Means corresponding elements are equal and y is equal to 2. So x is equal to 4 and y equal to 2. So here are the values of x and y. So here we are defining Cartesian product. As we have seen, Cartesian product is set of all possible relations, a set of all possible ordered pairs. We are defining in mathematical terms. So what do you mean by Cartesian product? It is set of all ordered pairs of elements of two non-empty sets P and Q. How we can write it as mathematically? Suppose let's say P and Q are two non-empty sets. Means Cartesian product is set of all ordered pairs of elements of this set. It can be written as P comma Q, where P belongs to set P and Q belongs to set Q. For example, we have taken two sets P and Q. Here 1, 2, 3 and A. So what is P cross Q? We have to operate on both sets to find all possible relations between these two sets. So we can write the first element should be of set first and second element should be of second set. Means one is related to A, similarly one is related to B. 1, B. Similarly for 2, 2, A, 2, B. Similarly for 3, 3, A, 3, B. So these are all possible relations. How we can find this? By using Cartesian product. What if we have to find number of ordered pairs or number of relations? If we have to find total number of possible relations between two sets, we use this number of elements in P cross Q equal to number of elements in set P into number of elements in set Q. This is the formula. Suppose for this example, we have to find number of elements in P cross Q. So number of elements in P, 3. Number of elements in Q, 2. Total 6 possible relations. Total 6 possible relations. So we have a question from Cartesian product. First question. Suppose there are two sets are given and we have to find Cartesian product between them. So P cross Q means all possible relations. It means relation between set A and set B. We can write it with A comma B comma C comma. This is P cross Q. Now we have to find Q cross Q. Means now from set Q to P. So R H R B R C. So here we can see P cross Q is not equal to Q cross P because as A comma R, here we can see second question. If set P is given 1, 2, what is P cross P cross P? A relation can be defined within the set or between two sets or many sets. So the relation here, it is a relation defined within the set. So what is P cross P cross P? Means we need ordered triplet now, right? This is an ordered triplet. 1, 1, 2. What are the elements in P cross P? Cross 2. 1, 2, 1, 2, 1, 1. And now, if P has two elements, means P cross P has 2 into 2 into 2, means 8 elements. Total, we need 8 ordered pairs. Means 1, 2, 3, 4. 4 more. Now, 1, 2, 2, 2, 1, 2, 2, 1, and yeah. So these are all possible relations. 1, 2, 3, 4, 5, 6, 7, 8, total 8. Total 8 possible relations. Now we move on to next question. If set A is given 1, 2, 3, set B is given 3, 4, and set C is given 4, 5, 6. We have to find this. First, we will find A cross B intersection C. Means all possible relation between set A and B intersection C. So first we need to find set A and B intersection C. Set A is here. We have set A, and here is the solution. Set A 1, 2, 3. What is set B intersection C? Common elements 4. So what will be therefore A cross B intersection C? What are the possible ordered pairs? Means relation is defined in A to B. Means first element is of set A and second element is of set B. 1, 4, 2, 4, 3, 4. This is our solution. Now move on to next. We have to find A cross B intersection A cross C. First we will find A cross B. What is A cross B? Means relation defined from set A to set B. Means 1, 2, 3, 1, 4, 2, 3, 2, 4, 3, 3, and last 3, 4. This is A cross B. Now we have to find A cross C. Means the relation between these both sets. Means first element is of set A and second element is of set C. So 1, 4, 1, 5, 1, 6. Similarly, 2, 4, 2, 5, 2, 6. Similarly, 3, 4, 3, 5, 3, 6. These are all possible relations. Now we have to find intersection between both sets. So what are the common ordered pairs? Here we need to find common ordered pair, not common elements. Or we can say common elements also. So here 1, 4 and 2, 4 and 3. So these are common ordered pairs or elements. and free flow. This will be our solution.